Hello, and today I would like to talk about the v-vector, or the velocity attribute. So, just to give you a quick overview, I have just a single point, and then in here I'm creating a velocity vector, which is looking something like that. So, I'm visualizing it like this. If you don't know how to visualize it, you can go here, click on this button here, and it should be already saved in your scene as a visualizer. You can also adjust the, let's say, color out vector, just like that, and all sorts of settings here, the length and so on. So I'll set this to 0 just for quick overview. And if you want to get the speed of a certain particle, or if you have a particle simulation or any type of simulation and you want to get the speed in meters per second, you just need to take the length of that velocity vector. That way, in this case, if I look at this, if I pop this into a, let's say, pop network here, where I'm going to disable the gravity, and if I look at this, I know that this particle is moving at a speed of 1.24 meters a second, because I know that that's how the velocity vector works. And just to give you a quick overview how in dot networks or dynamic operators work with this velocity attribute, so they'll simply take the current position and add 1/24th of the vector essentially. I have a quick vex code to just show it here. So in here, I'm taking the add p, creating a vector variable, which is a 1/24th of a vector velocity, and I'm just adding it to the position. And that's why actually how solvers work. Because if I show you here, this is my custom solver here. I'll actually disable the gravity for now. And I get the same result as I would get inside the pop network here. You know, the same result. So I'll show you how to recreate that, but first let's talk about the pop network here. So I also turned off the jitter birth because the jitter will essentially jitter the particle before spawning. And just to give you also the proof that this actually gives us the speed. So I know that my timeline is set to 24 frames per second. So if I start the simulation at frame 1, at frame not 24 but 25, if I look here, I get a position in the y-axis 1.24 meters because 1 second passed from essentially the spawn of that particle, and as we know, the speed was, if I visualize here, speed is 1.24 meters per second. We know in 1 second in the y-axis the point should have the position of 1.24. So I think I've proven this way how to actually determine the or how the v actually is being calculated inside the solver. So I'll create a new vector here, and now if I go to top in the pop network, we can see that we get a new angle. If I add a gravity, now it starts getting more interesting. We get this kind of shape here, or this kind of animation. So what essentially happens, I'll show it in a solver, because if I enable this gravity here, I get the same result here. So I think I already explained this here, but we want to create a gravity or a simple force. So what I'll be doing here is I'll be essentially taking, actually I don't need that, my bad. I don't need that. So we're just creating a vector, which is called, or a variable vector, which is called gravity. Then I'm just creating a essentially vector, which I can customize however I want. And I set up the gravity to be -1. I know that that's not physically accurate, but again, this is just for explanation, and you can create any sorts of forces here. Let's say I want to move it in the x. If I look here, it's going to actually work. So you can work the same way with all the forces. So in this case, I'm actually adding that gravity to my vector. So each frame I will add -1, or a vector which is pointing in the -1 in the y-axis to my velocity vector. And then what I'm doing essentially, I'm adding that velocity vector, which in return creates this type of effect, or that's actually how solvers work. Essentially, they update the position of that point based on the velocity. And since we're updating the velocity, let's say by adding a gravity to it, or we're adding some noises, like you would do here, you can add a pop force, pop force, which again, You can add a force here. By the way, don't mind this. There's supposed to be 3 columns or 3 different parameters for a vector. Or you can add with a amplitude, with a noise, different forces for each particle. And that's how the solver actually evaluates these simulations. So the simulations actually are not complicated, and that's how you can recreate them if you want to get more control. So, of course, as always, this project file will be in the description, and I hope you learn something new, and I'll see you again. Bye.